Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In today's video, we are going to learn about types of lubrication. Okay, this topic is from chapter 12, General Bearing, from the Chile Mechanical Engineering Design book. All the pictures here is taken from the book itself and also from Google Images. Okay, now let's continue in the topic. Okay, so there are five distinct types of lubrication. They are hydrodynamic, hydrostatic, hydrodynamic, boundary, and solid film. Okay, so what is an hydrodynamic lubrication? Hydrodynamic lubrication means that load carrying surfaces of the bearing are separated by a relatively thick film of lubrication as to prevent metal to metal contact. And stability as can be obtained by uh, the laws of fluid mechanics. Remember, this subject will involve fluid mechanics also. Okay, those uh, what you have learned in fluid mechanics, you will apply back to this subject. You should have some basic knowledge on fluid mechanics. Okay, then you can understand this subject better. Okay, hydrodynamic lubrication does not depend on direction of lubrication under pressure, though may occur, but it does require existence of adequate supply of all time. Okay, the plane pressure is created by the moving surface itself pulling the lubricant in the wedge shape. Okay, now let me explain what is an hydrodynamic lubrication. Okay. First, the general bearing itself is a general like this. This is a shaft. This is a shaft. You have learned. There is a one video. There is a. I have done a lot of video about shaft itself. Now, when you put the shaft in this cylindrical block, okay, in this casing is called general bearing. You can, if you can pause back and go into the first video, 12.0 on lubrication, or you can Google about general bearing. You can see typical image of general bearing. They have uh, this kind of cylinder block. This is for the mounting of the casing. Okay, this is a cylindrical block, and then there is a place for you put the oil. You put the oil inside here. Okay, the oil is inserted consistently. Okay, when is bearing, then a bearing inside here, it will become. You can imagine this is the casing. This is the journal. This is the journal, and this region is the region full of oil. Okay, region full of oil. We want to avoid metal to metal contact because, as you have learned in physics class, when metal to metal contact, it will become hot, and will become hot also. Uh, some particles in the metal will come out. Okay, when metal rub upon metal, okay, some particles on the metal will come out, and then uh, it will become wear and tear. So we want to avoid it. Okay, we want to avoid metal to metal contact. Okay, this is why this is called hydrodynamic lubrication, meaning that always all the time the fuel supply, oil supply, the meaning the lubrication supply is constant. Okay, this is called the hydrodynamic lubrication. Okay, this is the general bearing. Okay, I taken this image from Google image. Okay, you see here, let me explain. There is one slide will explain much better in this. Basically, this is the type of general bearing. You can Google this image. If you type general bearing in Google, it will come out with this image. Okay, this image translate into this. translate into this picture. Okay, this is a shaft. This is also this topic. This shaft is called as a journal. Okay, this is the oil wedge, and you can see the picture here. And when it is an wedging action, when it rotate, it will rotate up and down at any point of its position. The force become the wedge like this. Okay, the force actually not going to left only tau, it will go to up, down, left, right, all over the place. Okay, so this is the bearing, this is the journal, this is the load of because of the weight of the shaft itself, and also because the shaft is rotating all the time. Okay, so basically this is called the hydrodynamic lubrication. Okay, the theory of every theory that you will learn in this topic will based on this theory. Okay, this is the basic theory on hydrodynamic lubrication. If you understand this theory, you may understand other theory on hydrodynamic. Okay, let's move on to hydrostatic lubrication. Is obtained by introducing the lubricant, sometimes air or water into load bearing area at pressure high enough to separate the surface of relativity film of lubricant. So unlike hydrodynamic lubricant, this kind of lubrication does not require motion of one surface to another. We shall not deal with hydrostatic lubrication in this book, but the subject should be considered in designing bearing where velocities are small or zero, or where frictional resistance is to be absolute minimum. Okay, this book does not tell a lot about hydrostatic lubrication. It does not cover hydrostatic lubrication, but from this slide, I try to help you understand. If you are, if you have learned, if you have heard about minimum quantity lubrication in during machining, okay. If you have heard about MQL, minimum quantity lubrication in machining, okay, in the machining subject, not this subject, but subject related to machining. When you want to machine, you want to use CNC machining, turning machine, milling machine. In there is a field of knowledge using the minimum quantity lubrication, where you just spray using nano lubricant. This is for the whole new topic. Just I want to tell you, when you spray nano lubricant on the surface on of the subject that you want to machine, like you want to make turning or you want to make milling, instead of using coolant, you use this spray method, nano lubricant, meaning that it just uses a little bit of friction, a little bit of coolant to make the workpiece colder. Okay, this is again hydrostatic is a topic by itself. It does not cover in this topic, but if you want to learn better, start with minimum quantity lubrication using nano lubricant. It is a kind of hydrostatic lubrication. Okay, now yeah, this is the hydrostatic lubrication. We take this image I take from Google, from one um, uh, Indian lecturer give a topic. If you want better knowledge, you can see this video on hydrostatic lubrication. Okay, electrohydrodynamic lubrication is a phenomenon that occurs when lubricant is introduced between surfaces that are in rolling contact, such as mating gear or rolling bearing. If you remember, in the last video, not in the last topic about rolling contact bearing, uh, the topic about lubrication, okay, it mentioned about electrohydrodynamic lubrication. Okay, uh, in that video, I explained a little bit about electrohydrodynamic lubrication. Uh, it is in for rolling contact such as mating gear and rolling bearing. Okay, in rolling bearing, there is the type of bearing that uses grease. Okay, for uh, uses grease for rolling contact. Okay, for low velocity application, because at high velocity the grease may dissipate into the thin air. Okay, because of high temperature, it will dissipate. It will make the grease disappear into the air. Also, but alternatively, uh, if the bearing application, the rolling contact bearing application is for high speed, you should use oil. Okay, uh, the mathematical explanation requires Hertzian theory of contact stress and fluid mechanics. Okay, I don't cover a lot in Hertzian theory and fluid mechanics. You can go back to fluid mechanics subject. Okay, to learn about Hertzian theory and everything. Okay, boundary lubrication, insufficient surface area, a drop in velocity of moving surface, lessening the quantity of lubricant delivered to a bearing, increase of bearing load, increase of lubricant temperature, resulting in decrease of viscosity. Okay, any of these primary build up of film thick enough for full film lubrication. When this happens, the highest asperities might be separated by lubricant film only several molecular dimension in thickness. This is called boundary lubrication. Change from hydrodynamic to boundary lubrication is not all sudden or abrupt one. It is probable that mixed hydrodynamic and boundary type lubrication occurs first, and for the surfaces move to get closer together, the boundary type lubrication becomes predominant. Viscosity of lubricant is not as much important with the boundary condition as in the chemical composition. So uh, it is like the same theory as MQL. Okay, uh, but better explain about boundary lubrication using as this MQL than hydrostatic lubrication theory. Okay, because you just need a uh, little bit of uh, uh, lubrication, little bit of lubrication to 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 avoid uh, to avoid friction. Okay, to minimize friction. Okay, okay. So this is the some pictures I take from Google about boundary lubrication. Okay, so I mean you see here. Okay, this is the difference between hydrodynamic lubrication that in the first slide. You see the oil is many. Now boundary lubrication, the the lubrication is very minimum, very minimum. So it has its application, it has its advantages, so that your general bearing is not that too messy. Okay, it's not that too oily. Okay, sometimes when you do maintenance, your hand becomes so oily. Okay, so using boundary lubrication, of course it requires lubrication properties, better lubrication properties. Okay, so that it your hand is not that oily. Okay, and then the the last one is solid film lubricant. When bearings must be operated at extreme temperature, a solid film lubricant such as graphite or molybdenum disulfide must be used because ordinary material oils are not satisfactory. Much research is currently being carried out in an effort to find composite bearing materials which low wear rate as well as small frictional coefficient. Also, this is the challenge. Uh, this book also does not cover a lot about solid film lubrication, but just want to say that nowadays bearing is used in many application in extreme temperature, so needs required new kind of material, and also new kind of lubricant. Okay, ordinary lubricant, when operate at high temperature, it will dissipate into thin air. Okay, because extreme temperature will burn all the lubricant. Graphite, molybdenum, and all other materials which had high melting temperature, it will not easily dissipate into air. Okay, because its melting temperature is high. So this is why it is an ongoing research. Many research nowadays also, it is ongoing research on this topic itself. Okay, so uh, so let's learn the theory first about the hydrodynamic lubricant, and then you so that you may understand the basic theory, and then that basic theory you will apply for more, for those lubricant like this solid film lubricant and anything. Okay, so that's the end of this video. We see you in the next video on viscosity. Thank you very much.